Hey everybody, let's take a look at the code trails. So what are the code trails? Code trails are kind of a short exercise which are practical, and we call them pizza bite kind of code trails to really help you go through a quick coding challenge and exercise your mind and practice some relevant coding skills. With AI today, coding quite a lot. We as a developer code review pretty much a lot of the times per day, and being able to kind of capture the code that smells and ask AI to fix the code for us, redo the edits to really kind of comply with our own coding standards is really important skill. So this is basically what essentially code trails are about. So they create kind of a challenge for you in the code based on what topic you want to practice, and then with the help of AI or just by doing the coding changes yourself, you transform it in a way that would represent the better version of the code. So let me show you how it works. Here you have kind of a predefined coding challenges, especially if you click on coding, because we have also architecture, which is more diagramming, and requirements, test cases, which are going to be text-based, engineering management, which is going to be again diagramming, QA and DevOps diagramming, and process metrics is going to be diagramming. Coding are like code exercises. So let's take any of those and practice them. Let's say we go with the clean code refactoring. So here I have different languages supported. I can click on Python. Basically, what I can also do, I can select any other language from here. So I can go with Go, C#, whatever language I have in mind. But in the meantime, I'm going to stick to Python. And I can change the level. Let's say this one's going to stay intermediate, but I can also go into advanced, expert to beginner. And the clean code, this is what I want to practice. As well as I have kind of a definition of the challenge that I want to try, practice, solve. And as I click generate trail, LinkBlink will come up as a real life scenario in code representing this sort of problem, and then expect us to kind of refactor the code. We could do that either ourselves or we could do that with the help of AI. So let's see how it works. So we have slicing complexity challenge, and this is the story. So this model handles basic data aggregation and filtering, and the existing code suffers from several issues. A leading function responsible for too many tasks, high cyclomatic complexity due to deeply nested logic, and some other problems. And we have three quality criteria. So the first is reduce function size, the second is improve complexity, the third is enhance readability and naming. And we have learning objectives like apply SRP, improve efficiency, and refactor unclear variable and functional names, and a couple of hints. So let's start coding. So here we have a code. So we have the process and combine data function, which takes the raw data, filter key, mean, and max, and then it does the processing for us. So it has the for cycle, which goes through the item to process, and then it basically applies filtering, the transformation, and it does the sum up, and then it basically stores the item ID, the adjusted value, and the status. Okay, so let's transform it. So what we can do is basically we can check how we can first split this up into kind of, if you need to, a couple of service functions so that they have a single responsibility. Let's say the first responsibility could be kind of this criteria, the second would be maybe this one, or the processing would be definitely separate. So let's go and see what hints we have. So the main function process is doing too many things because they're distracting two key helpers. Okay, let's go with that. We can also do our own edits, or we can instruct the AI to do edits for us, especially something that we see needs to be changed. We can also select in the code and just do fix with AI to help that code be fixed and get a better shape. Okay, so let's take a look what's changed. So we currently have the transport value added as a service function. We have generate summary added, and we have process JSON data is now using this functions instead of having the code baked in. Okay, that's great. So this one is still kind of a little bit large. Let's see generate summary what it does. So it takes the length of the adjusted values. Then if it's 0, it returns the stuff. Okay, this is not great that we use just the dictionaries. I think we should use kind of dedicated classes for it, and we should define them for that instruction. Oh, by the way, you can just kind of click here and just say fix with AI and say, okay, let's add a class representing the entity and use it across the code. And that will help us to be a little bit more strongly typed, which is always better thing to have this kind of contract even on a smaller code base, so that it's clear what do we work with and what characteristics this entity has. Okay, so we currently have the summary class, which is added, and we have functions now using it, but we don't have strong types here added. So I guess we need to fix that. We can say, okay, use types in the function signatures, so that the more strongly typed we are, the better. Obviously, it also helps to maintain the code easier when we see what the function expects, what type of values are going to be used. And since we already introduced it, we better use it. Let's see. Okay, so now we have the type specified. We have integer here. We have the list of integers here. And we have the types here defined as well. So let's see. How do we actually use the summary? So we expect when we generate summary to return the summary. And it uses kind of the adjusted values that we provide. And here we have the process JSON data, where we have actually basic exception handling. And we don't have the exception handling anywhere else. So we need to add it. So let's say add exception handling for the corner cases, and basic logging. Oops. Yeah. So let's see how it's going to refactor the code, and let's see if that's everything we want to change, or there's going to be some additional work to do. Let's see. And we also can check what are the hints. So maybe there's going to be some kind of a viable hint there that we would want to do, just to make sure that the code is actually clean as it should be. And again, you may have actually higher clean code standards than in hints, and you should definitely apply those. Okay, so we have try except block for just sound decoding, value summation. Let's see, so what do we have here? And you can go to the step back and just see what was adding. So we had the logging added, and we have this tab added logging when we parse JSON, and we have when we do let me see. Okay, all right, this makes sense. This makes sense now. Okay, and in general, it looks good. So I think we basically have everything we need to submit it. So it looks better. Now it's not one function doing everything, but we have data types defined, and we have the exception added, the logging added, and we have a kind of, more clear responsibility in functions. So let me try see what else hints we had. It's variable names, and also, okay, this is what we did. And nested. Okay, so I think we're good enough. Let's try and see if we did well. So we're going to complete the trail and see what's going to be the results of the final review of the code that we kind of refactored, and what pros and cons of our refactoring is based on the criteria that we had to nail with this exercise. So we have 89, which is not bad. So we have a couple of good key achievements, like decompose the monolithic function and the logging and other things. There are a couple of things to improve. Okay, so this is documentation that I mentioned. So this thing is kind of redundant, which, yeah, probably is the case. So we would probably need to spend a little bit more time there figuring this out. Okay, this is what I was mentioning, that probably we should log the items and kind of retry them, or just kind of, return what we processed and what we didn't process. Yeah, this is what I missed, and some other things. So this is interesting. But generally, on the reduce function size, improve complexity, enhance readability naming, we did kind of not bad. And we can always go back and see what were kind of the code delta we were generating, as well as we can go through the step-by-step kind of changes that we've had and how we've worked with the code right until the current code, which has the final solution, as well as the code delta from the very original one to the one that we kind of refactored. So this is how you practically can go through the refactoring and see if you spot all of the errors that and the code that smells in all the different exercises. They could be, as I mentioned, very different. And you can also go with any of your kind of topics for the exercise, as well as you can just go ahead and click Feeling Lucky, where you're going to be able to kind of have AI create for you different topics based on the language of your choice. Let's say in my case, this is Python, and you can select the difficulty. In my case, it was intermediate. We can also go with all the different trail types. Let's say you can do performance, you can do refactor in general, you can do security, and then you can type a specific focus of what those trails should be focused on. But you can also go with an Easter egg, and if you go with an Easter egg, then you're going to see them like this with the hidden description, giving you a little bit of the surprise of what you're going to get after you kind of open the trail. And this one, those are not the Easter egg. You see them with the description stuff. So if you want to have a little bit of surprise, just put the topic here and generate based on what you have in mind, but hide the kind of description so that you could be solving without preparation. So I hope you enjoyed this short demo, and hope to talk to you soon. Bye-bye.